We refer to this as a turbo lamp stack because each of the components contribute to the overall performance of the stack. The POWER8 system with its 3.42 GHz processor and 8 processor threads per core and a high-speed memory bus. PowerKVM's PCI pass-through, which enables a VM's direct control of the adapter to maximize adapter performance. The Mellanox 40 gigabit per second intra-VM networking backbone. Ubuntu's Little Indian operating system for POWER8. MariaDB that's been optimized to exploit POWER8's 8 threads per core with a 2.2 times socket-to-socket performance improvement over x86, and Xen's PHP server with its enhanced PHP engine. This is a demonstration of the deployment of the TurboLamp software stack on top of a Scale-out POWER8 system. The demonstration will take you through the provisioning of the VMs, the booting of the OS in each of the VMs, and finally the deployment of the TurboLamp stack utilizing Canonical's MAS, Metal as a Service, and Juju Charm framework. The LAMP stack is able to run any PHP-based business applications. For this particular demonstration, 2 popular business applications are deployed on top of the TurboLamp stack, Magento and WordPress. The demonstration utilizes the hardware topology shown. The system on the right is hosting Canonical's MAS and Juju deployment infrastructure. The system on the left is the target system where the TurboLamp stack will be deployed and is configured with the Mellanox 40 gigabit per second LAN network components. The IBM Power Systems S822L comes with PowerKVM pre-installed. PowerKVM makes available several management interfaces. For this demonstration, we'll be using the Versh CLI command line interface and Kimchi Web Interface to manage and monitor the VMs. Now switching to the PowerKVM terminal session. Off camera, we have created a set of 4 domain definition files. These XML-based configuration files describe the characteristics of the VM we want to provision, the number of processors, the amount of RAM, disk space, etc. For this demo, we're using a technology preview of PowerKVM PCI pass-through that enables us to dedicate a Mellanox adapter card to each VM. The screen displays the invocation of a script which invokes the Versh create command 4 times, once for each VM. Let's log into the Kimchi Web Interface. The Kimchi interface allows us to monitor the host system status as well as the status of each of the guests. Each of the guest VMs can be managed from this screen. You can see that these 4 VMs are in process of starting up. The Kimchi interface provides live tiles that we can click onto to gain access to a terminal session with each VM. The deployment topology diagram has been updated to show the 4 newly provisioned PowerKVM VMs running on the target system. In this part of the demonstration, we'll be using the network performance measuring tool iPerf to measure the performance of the intra-VM network connection provided by the Mellanox driver, adapters, and switch. We'll start the iPerf server component on VM2 in the lower right portion of the screen, and the iPerf client with 8 threads on VM1 in the upper left of the screen. We mentioned earlier the use of PowerKVM's PCI pass-through function to enable the Mellanox device driver to interact directly with the Mellanox adapter card. This enables maximum performance from the adapter and is one of the factors contributing to the high-performance LAMP stack. We have sped up the video so you can see interim bandwidth reports being created at 5-second intervals. We're achieving around 37.5 gigabits per second bandwidth. Once the test completes, the results are displayed. You can see we transferred 262 gigabytes of data in the 60-second test run. Once the VMs are up and running, they're available to be managed by Ubuntu's MAS, Metal as a Service, and Juju framework for TurboStack deployment. From the MAS console, we see the 4 nodes or virtual machines that will be used to deploy the TurboLamp stack, and the 5th VM used to run the MAS and Juju GUIs. The Juju GUI provides a graphical representation of the solution. Here, the user can simply import the solution onto the canvas and the services begin to deploy. Command line folks, no worries. Here you can see Ubuntu 14.04 installed on POWER8 with Little Indian and the status of services being deployed by Juju. All of the services have been successfully deployed from scratch with a fresh Ubuntu OS install, and the full Turbo LAMP stack solution can be viewed. Mellanox provides drivers for high-speed data transfers between MariaDB and Xen, a common bottleneck for LAMP stacks. MariaDB provides an SQL data store for Xenserver, which is serving out PHP applications such as Magento. Xenserver has the ability to be clustered for additional performance, and thus can be proxied behind HA proxy. And these applications have just been deployed, and we need to find the IP addresses to see the running PHP application. We can see Magento is live and running an e-commerce sample site. We can also check the Xen server console and see that it's alive and well. These services were developed by the experts at SkySQL, Xen, and Mellanox, and tuned for Power8 with Little Indian so users know they're getting a recommended and high-performing solution. The Juju Framework deployment of the Turbo LAMP bundle has updated the 4 virtual machines running on the target server. Another logical view of the configuration is shown in this next diagram. VM1 is being loaded with the load balancer and connected to VM number 2 and 3 over the Mellanox high-speed network. VM 2 and 3 are being loaded with Xenserver and the sample business apps, Magento and WordPress, and then connected to VM 4 over the Mellanox high-speed network. VM 4 is being loaded with MariaDB that's been optimized to run on Power8 hardware. Now let's take a look at one of the business applications we've just deployed, Magento. In this example, we're browsing an online store, selecting items for our shopping cart, and checking on the status of orders. Magento is using the Xenserver as its PHP engine. As the application runs, key performance information is collected by the Xenserver and is displayable via the Z-Ray interface. The Z-Ray information bar is at the bottom of the browser window. It provides various performance metrics and program information to system administrators and developers. This kind of information enables application developers to quickly diagnose performance and other code-related issues with business applications. Here, for example, we can see every PHP function that this page executes, the count for every function, and the data about the duration of execution time. We can look at variables, including session variables and cookies. We can see both the current and previous value of a variable, providing valuable insight into the application. Let's take a look now at the Xenserver browser-based dashboard now that the Magento business application has been exercised. Xenserver gives you valuable information about the performance of your application and lets you choose how much performance history you want to retain. For our Magento application, we can capture statistics about the most time-consuming pages. We can look at pages that had the slowest response times. And we can also look at pages that are the most visited pages in the application. From the dashboard, you can gather information about all of your applications and review the various configurations. For example, you can look at the Xenserver components you have configured, and you can look at the PHP components, both those built into Xenserver and those you may have loaded yourself. Xenserver also lets you decide when to make Z-Ray available. You can enable it for development only, or for development and production. Z-Ray helps developers write better code faster. Now we'll take a moment to look at another business application that was installed as part of the Turbo LAMP bundle. We'll use WordPress and its corresponding iPhone mobile application. On a browser, we navigate to the WordPress welcome screen, we'll log in and add a comment to a recent blog posting. Over on the mobile device, we've installed the WordPress mobile application along with a VPN client required to access the WordPress server running on the Turbo LAMP stack as seen on the left-hand screen capture. The center screen capture shows us viewing the post about the large campfire and the ranger's comments. The right-hand screen grab shows us making a new post with the mobile device. Users coming in through the browser interface see the new post from the mobile device as well. This completes our demonstration. In summary, we demonstrated starting with a Power8 Scale-out Linux server that comes with PowerKVM pre-installed, using one of the PowerKVM's management interfaces to provision 4 virtual machines, the Kimchi Web Interface to Power KVM, which allows one to monitor and manage the virtual machines. Demonstrated the intra-VM throughput provided by the Mellanox 40 gigabit infrastructure. Using Canonical's Metal as a Service or MOS and Juju framework to deploy a complete application bundle. The bundle was a collection of charms and relationships required to deploy a completed business application. A cluster of 2 Xenservers coupled with an optimized for POWER8 MariaDB database. The bundle of charms encapsulated the experience of subject matter experts in a single reusable deployment unit. We deployed 2 sample applications, Magento and WordPress, on top of the Turbo Lamp. We utilized the Xen Z-Ray feature to look at the performance characteristics of the Magento application as well as the Xenserver dashboard. Finally, using WordPress and its corresponding mobile application, we demonstrated a mobile device interacting with the Turbo Lamp stack. If you'd like more information about Turbo Lamp, email us at tlamp, that's TLAMP, @us.ibm.com.